Hello everyone, this is Snigdha Kakkad and this is my channel AccelerateAICareers. Yesterday we solved a problem LeetCode 55 Jump Game 1 which has been asked in Amazon and Google interviews in last 6 to 12 months. So this is the next level of that problem, Jump Game 2 LeetCode 45. If you have not solved the Jump Game 1 problem yet, watch the video first. I would highly recommend to solve that problem using all the solutions possible, understand each approach, and then go forward with this particular solution, okay? Jump Game 2 has been asked in Amazon and Google interviews. It's a medium level problem. What does the question say? So you are basically given a zero indexed array, nums, which is of length n, and you have been positioned at the beginning of the array, that is at the zeroth index. And it's an array of totally positive integers. And every digit in the array represents the maximum number of forward jumps you can take from that particular index I. In other words, like if you are at say 0th index and the value there is say 2, so you can take maximum of 2 jumps or less than 2 jumps from that particular index. So question 55 jump game 1 actually asked you to find whether it is possible for you to jump from 0th index and reach the last index by using the jump values possible in the array. If yes, then return true. If not, then return false. That was your jump game 1. So I would highly recommend to go back to that video, watch it first, and then start ahead with this video. Now, in this particular question, what the examiner wants, they don't want to know whether you will be able to reach the last index or not. They're giving you that as an assumption that you will be able to reach the last index. But what they want is which is the minimum number of jumps in which you can reach the last index. That is nums n minus 1. So you don't need to find out whether you can reach or not. You have to find out how many jumps are needed at the bare minimum to reach the last index. So for example, the nums here is 2, 3, 1, 1, 4. So if you start from 0th index, you can take either one jump and reach digit 3, or you can take 2 jumps and reach the second index, which is digit 1. Now, if you reach the second index, digit 1, then you have to take one jump at max. So you reach the third index where the value is 1, and again you take one jump and reach the last index. So essentially you are making 3 jumps there. You are first going from 0th index to second index, then second to third, and then third to last. So you're taking 3 jumps. Just assume you are not taking 2 jumps in the first. You are taking one jump in the first, and you are reaching the first index where it is possible to take a maximum of 3 jumps, and you choose to take the 3 jumps there. So you take 1, 2, 3 and you reach the last index. So essentially how many jumps do you take? One jump to reach first index and then one jump to reach the last index. Hence the output is 2 because it takes the minimum of 2 jumps to reach the last index. I hope the question is clear to you. Let's delve into the algorithm of how to solve this question, and finally we'll go to the coding part. Mention any questions you have in the comments. If you know a better approach to solve the question, do let me know. I would love to learn from you. Now, like jump game 1, there are multiple approaches to solve this question. You can solve it using DP as well, dynamic programming. While we tried those approaches for jump game 1, I'm not going to go deeper into them because either they require some extra memory or they have a high time complexity. Instead, I know there's a better approach that exists, and I'm going to go deeper into that, which is the greedy method approach that we ended up using in jump game 1 as well. So the greedy method approach can yield O(n) time complexity here. It's the easiest approach for this particular question, and once you understand it, you will get a knack of using it in similar questions. So let's see how that approach works. So in the given example, 2, 3, 1, 1, 4, what we will do is whenever we have the number of jumps mentioned here and we decide to take jumps, we will not mark the options where it can jump, the indices where it can jump. Instead, we will mark the range of indices it can jump to, and we will mark them in one range. Okay, so for example, at the 0th index it is at step 0, it has not jumped yet, so that is one band. Okay, and from there it says that it can take maximum of 2 jumps. That is, it can either take one jump and go to index 1, or it can take maximum, that is 2 jumps and go to index 2. So the range to which it can cover is from index 1 to index 2. That's why I have highlighted it in different color. So within one jump, it can cover this entire band of index 1 to index 2. Now say suppose it takes some jump, and after one jump, what's the next width which it can cover? So the next width which it can cover is decided. Say suppose it first jumps to index 1, and index 1 says that it can take a maximum of 3 jumps. So it can either go to index 2, or it can go to index 3, or it can go to index 4. So you will discount any those indices which are there in current band itself. So like index 2 is a part of current band highlighted in green color. So you will skip that. Whereas the other two indices which are index 3 and index 4 are a part of outside this green band. So you can consider them as another band where you can take another jump and reach. Now say suppose you initially didn't take one jump, you took 2 jumps and reached index 2. That is, now you can take one jump at max. So that will allow you to go to index 3, which is covered in your red band. So basically, as you can see, if you make one jump, you cover index 1 to 2. If you make 2 jumps, you cover a range of index 3 to 4. Hence, the total number of jumps which are needed to reach the last index are 2. So essentially, it's a simplistic form of breadth first search if you see. So you are not going into the depth, you are swapping the breadth of each window. So basically, you will be using left and right pointers, and then you will be deciding how much sweep it can make within one jump and calculating the number of jumps needed until the rightmost index or the right edge of your window reaches the last index. I hope the approach is clear, and this is your linear time complexity approach. So ON time complexity would be taken because you will be doing a linear sweep across the entire array, and you have been given a one-dimensional array in which you are doing the simplistic breadth first search. So let's start coding. Now, if you understand how to solve this question, the coding part is really easy. So let's dive into it, how to do it. So I'll first define the variable in which I'm going to capture how many jumps bare minimum are needed to reach the end of the array. So right now I will initialize with 0 since we have not made any jumps yet. And I'll also initialize the 2 pointers tracking the width or the breadth of my window, the moving windows. Right now, since I'm starting from index 0, so my left pointer and right pointer both will be pointing to 0th index. Hence, I've initialized it from 0. Now, until when do I run the loop? So I will run the loop until the right pointer reaches the length of nums minus 1 until the end of the array, because I need to calculate the number of jumps till then. So now I will define a variable farthest, and I'll also initialize it from 0. So I need to calculate how much farthest from that particular index the jump can be made. So, and I will be updating that. So from current index for I in range left to r plus 1. So I am particularly tracking from one window to the next window. So one window starts from left pointer, ends it at right pointer. In Python, we always take the last index plus 1 because the last value is not included, and hence r plus 1 here. So for I in range L to r plus 1, and what we will do, we will be updating our farthest value here. So how much maximum jump you can make. So farthest would be max of farthest. And what would be the next value? The next value would be your current index, whatever your current index in the current window is, plus the number of jumps you can take from current index, which would be nums of I. So essentially, you are updating farthest either to the max of farthest, which is the current value, or the current index plus the number of maximum jumps you can make from that index. So once you have looped through the entire loop, you can update your left and right pointers. So you will be updating left as I showed in the prior demonstration. You will update the left pointer to r plus 1, and you will be updating the right pointer to the farthest, because that is the maximum jump you can take from the prior window, and hence the rotating window will move this way. And don't forget to increment your number of jumps, because every time you move your window, that is you create additional range, you have to increase the number of jumps. And finally, this is our code. You just need to return the number of jumps you have made. And let's see if our code works. So it's accepted. Let's submit. Okay. So it works fine. So I'll just give you a brief walkthrough of the code again. So we first initialize the total number of jumps needed. Then we initialize the left and right pointer of our window, like our rotating window, which moves on. Every time the number of jumps we are hitting, every time we are taking one jump, we are moving the left and the right pointers. And until when do we move? Until the right pointer reaches the end of the array, that is length of nums minus 1. So while right pointer is less than this, we initialize a variable called farthest. And what does farthest signify? It signifies the maximum number of jumps you can take from a particular index or from a particular band, okay? So in the particular band, how much the band ranges, it starts from left pointer, reaches till the right pointer. And hence for I in range L to R plus 1, and you update the farthest to maximum of farthest and the current index on which you are within the current band plus the number of jumps you can take at max from that index, I plus nums of I. So whatever farthest value is, that ways you rotate your next window. So your left pointer gets updated to R plus 1 and your right pointer gets updated to farthest. That's your next window. And don't forget to update the number of jumps every time you rotate the window. And finally return the number of jumps. I hope the solution is clear. If you like my way of solving problems, subscribe to my channel Accelerate AI Careers to get notifications for your daily LeetCode challenge. Let me know if there is any specific problem you would prefer me to solve first. If you have any doubts, mention in the comments. I'll be happy to address. Thank you.